So, quick reminders to get us started. So PLQ3 still due Friday, second step due Monday. I saw that a bunch of you already took the first step, so that's perfect. Some of you have had a lot of questions about PLQ3, that's normal. Okay, this one, and I'm going to take that into account when I grade it, but this one is a lot more complicated than the standard GQ that you have. The intent is the questions that are being asked of you this time are meant to make you, to force you actually, to put all the pieces together. That's why they are like a lot more open up for discussion and comparison, etc. On the plus side, you don't have a time limit, right? So you can open PLQ, you can read it, you can start thinking about it, you can even talk about it with the TAs, with me, with other classmates. You have time, okay? If necessary, it's not unusual for that kind of question to force a student to go back to the lecture, to go back to the readings, you know, just to refresh their definition of what polymorphism actually is. I've seen a lot of questions that come from the fact that you remember part of the definition of polymorphism, but you don't remember it, you know, in a very formal way, in a very strict, rigorous way. So you have like, you hit some of the target, right? You say, well, polymorphism is about this and this. You look at the example and you see, well, this example is about this and that example is about that. So I'm confused. Every polymorphism is everywhere, right? When that happens, that's not a bad thing. When this happens, that just means your definition of polymorphism is a little too vague. We can refocus it in office hours. You can refocus it yourself by just revisiting the study material. And once you do that, you're going to look at those exercises and you're going to have a completely different perspective, okay? And that's exactly the point of those exercises. Force you to have this full perspective on those concepts before we hit the final exam. All right, what about IE4? I thought about it carefully, I hope carefully enough, and I decided the following. So last slide, I was saying that IE4 would be due Tuesday. I'm going to release it Tuesday, so that those of you who want to get rid of it before, you know, they travel for Thanksgiving, etc., you can still do that. So you can take it by Tuesday midnight and be done with it. A few of you have asked already for a little bit leniency in the deadline. I'm pushing it to Wednesday. So the absolute deadline to turn it in is Wednesday. I still want to avoid infringing on, you know, the whole few days that you might have at the end of the week to just try to recuperate, recharge those batteries before you go for the final push and the final exam, okay? And other than that, well, yes, the schedule is still the same. Still reminder about the evaluation. So last time I talked at length about the student evaluation of the course, very important stuff. This time I'm just going to skip in 30 seconds. I just wanted to put that in the slide as a reminder. The link to take the evaluation should be open now. So please give it a shot and share your thoughts using that medium. This is where we stopped last lecture. So last lecture we were going through the first of two remarks, okay? And the first one about exception was a similarity between what's happening when we catch, when we have several catch blocks, okay? And when we use instance of. When we use instance of and we wanted to detect if a certain object was an instance of different classes, we could have a bunch of successive if statement. If my object is an instance of employee, then do that. Else, if it's an instance of faculty, then do that, okay? And then what we talked about when we discovered that technique is the order in which you make your test matters a lot. If you test first if an object is of class employee, and then you test if it's of class faculty, well, two scenarios can happen, right? I give you an employee or I give you a faculty. If I give you an employee, bingo, it works. If I give you a faculty, guess what? Faculty is subclass of employee, so is a faculty object an instance of employee? Yes, always. That's the definition of inheritance, okay? That's what enables polymorphism. So if you do that in that order, then your first if statement is going to always catch all the cases, and you're never going to get to the second. Well, exactly the same situation happens here, for exactly the same reason. The catch block, they are kind of like if statement in disguise that are trying to take that exception object and they ask that exception object that has been thrown at them, they ask it, are you an instance of blah? and blah would be the class name that you are using for the catch, right? So they are testing to check, what kind of object they are dealing with. They are doing it the same way that instance of does it. And because of that, the order matters. If my first catch block is catch exception, that's a superclass of all exceptions, right? Well, I'm done. I can put like 25 catch blocks after that. They are going to be all about subclasses of exception. Nothing is going to happen. Okay? So that's the first thing I wanted to warn you about. And it's interesting because it's showing just how polymorphism and inheritance permeate everything. Okay? Let's say I don't want to learn about OOP concept, I don't want to learn about inheritance, I don't want to ever use inheritance in my life. Do I want to ever be able to use exception? Probably. Will I have to handle exception from method that I call? Yes. As soon as I start doing input-output on a file, I don't have a choice. To be able to do that, it's more comfortable if you understand why things are ticking this way. Okay? And it's going to be true for a lot of frameworks that you're going to have to use during your career. We said that there were two types of exception, okay? Checked and unchecked. And I told you, unchecked, you may deal with them, you don't have to. Checked, you have to deal with them. So what did I mean by you have to deal with them? I mentioned previously that it was a compiler forcing you to handle checked exception. Every time there is a checked exception on the horizon, even if it's not triggered, if it has the potential to be triggered, you need to be ready for it. Okay, and that's enforced at compilation time. So what does it mean, handling the exception? Well, now that we have been going through all of the syntax and all of the different aspects, of using exception in Java, we can put like a more formal definition to that. Handling an exception means one or two things. One, you can catch an exception. And this is generally what we mean by handling an exception. Meaning if I call a method, I know this method might actually raise an exception, I'm going to put it inside a try block, and I'm going to put one or more catch blocks afterward. Okay? That's handling the exception. Kind of like sandbox it, sandbox the stuff that can go boom, and then write the code that is supposed to be triggered when this or this or this or that exception occur. Okay. There's another way to handle an exception, however. The other way to handle an exception is I don't know what to do. I don't know what to do if I have an arithmetic exception from this method or if I have an input-output exception from that method. I'm just like a middleman. I'm just a function, a method that has been called to do a job. I need to call this other method to do a job. It might fail, but if it fails, I don't have the authority, I don't have the knowledge, I'm not in a position to do anything. So when you're cut like that, when your code is cut like that in the middle, what you do is, we say you declare the exception. So if I call a method, that method may actually raise an exception, and I don't know what to do with it, well, I just declare myself as blah, 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 method, blah, 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 throws that same exception. So I just say, watch out. When you call me, I may throw this exception. To be very pedantic, technical, accurate, it's not me really throwing the exception to start off with, but it's one of the methods I call. But you know what? Since I don't know how to handle it, I'm going to just pass it around. I'm just going to keep propagating. So these are like your two primary approaches to quote-unquote handling an exception. You do something with a try-catch block, you remediate the situation, or if you don't know how to fix the problem, you just pass it along to whoever called you. And you remember from last lecture? It bubbles up. So whoever called you has the same choice. They can try-catch the exception and handle it, or they can handle it by just passing it to whoever called them. And we go up the chain like that of who called who, and we end up with the main method. And if the main method cannot handle the exception with a try-catch block, then it's going to let it bubble up. It doesn't even have to declare it. It's just going to go to the JVM. The JVM will shut down and display the error message that you have been seeing already a few times, in your career. All right. So this is what it looks like. We have a method P2 here. The method P2 throws an IO exception, so that's a checked exception. If the file doesn't exist, then throw new IO exception. The file doesn't exist. Okay, so this is a method that is likely to fail. Okay, that detects an error condition, that throws an exception. it throws the exception here, it declares that it throws the exception. And in response to that, if I have a method P1 that calls P2, these are the two scenarios that we have been talking about until now. First scenario, a try-catch block. I contain the method that may fail, and I provide code that remediates the situation, very important. And if that code ever executes, then Java assumes that we can resume execution here, and everything is well. And then second possibility, second strategy, I call P2. I don't even bother putting it in a try-catch block because I know I cannot do anything meaningful to recover from an error. So instead, I declare that I will throw that IO exception. And all of that is mandatory if you deal with an exception that is a checked exception. The compiler will force you to either have a try-catch block or have like a declaration. You need to be able to do something. And then it propagates that constraint to whoever called you. They need to have a try-catch block or a declaration. And it's going to check throughout all of your code like that somewhere, somehow, some piece of your code is going to be able to handle the situation. There's a third possibility, actually. So the first possibility is to try and catch. The second possibility is to declare. Well, the third possibility is kind of a mix of the two. That's not the common choice, but it exists, it's there, it's available, so it's good to be aware of it, just in case you encounter a scenario that requires it. The third possibility is called rethrowing an exception. Don't get that confused with, just declaring the exception, like passing it around. Passing it around means that I don't handle it, I don't touch it, I just pass it to whoever called me, they can deal with it. Okay, that's what we did when we declare. Here, we are talking about using a try-catch block. So it's kind of like the first of the two solutions that was on the previous slide. And then inside the try-catch block, if we catch an exception, we are going to do a few steps. We are going to take a few steps to remedy the situation. But the assumption is that maybe we are able to log the problem in a log file. Maybe we are able to do stuff like that. But we are not capable to resolve the issue entirely. Not in this part of the code. So now what we would like to do is we would like to let the exception bubble up. But it won't. Once an exception has been caught, that's it. You're supposed to process the problem, find a solution, and then execution resume normally. So I cannot just declare the exception and hope that it's going to bubble up. So I have to do one more thing. I have to try and catch it. I have to declare it in my method, so that other method knows that potentially I'm going to throw it. And then I have to explicitly use the keyword throw to propagate that exception upward. Okay? So it's kind of an hybrid in between. I can fix the problem, try-catch block. I can partly fix the problem, but I still need to pass the exception to whoever called me. That's this method. Or I don't know what to do. I'm just going to declare that I throw the exception, and if I get the exception, it's going to bubble up automatically. Okay? These are the three strategies that we have at our disposal. So, the table summarizes everything here. So it's you are blank a method that throws that kind of exception. So if you are writing, if the blank is writing, so if you are writing a method that throws what kind of exception, checked or unchecked. If you throw an unchecked exception, you may actually declare and throw it. Okay? The declare step is even optional, but generally when we throw something, we declare as well. So declare and throw. If you are trying to call a method that throws an unchecked exception, then it's everything goes. You are free to handle it. You are free to not handle it. You are no obligation from the compiler point of view. Okay? It's only when it's checked, when you are trying to call a method that throws a checked exception, that you have to choose one of those three strategies, which are the three strategies we just discussed, in the previous slide: catch and handle, declare, or rethrow. One last piece of syntax, one last keyword. This is actually the last keyword we're going to uncover for exception handling. The keyword is finally. It's kind of like a clause, just like the try block, the catch block. Well, we can have at the end of our try catch one finally block. And we can have only one of those. Okay, it's unique. You can have multiple catch blocks. You can have only one finally block. You can have only one try block in one of those structures. What is the goal of the finally block? It's to guarantee that some statements are going to be executed no matter what. What do I mean by no matter what? I mean whether there was an exception or whether there was not an exception. Okay? Either way, I want some code to be executed. When can this come in handy? Well, if you have, for example, files. You open files, you are ready to read and write into those files, but when you try to read and write, you realize that you don't have permission, for example, to write. So an exception is raised. So the execution of the try statement interrupts. We go into the appropriate catch block. We execute the remediation code. But then after the catch block, at the end of the catch block, you would want to close your files, right? Okay, so let's put it in the catch block. But what if I catch another exception? Like instead of permission denied, I get something that is in the lines of file not found. Well, I'm going to have another catch block, and I'm going to remediate that problem, like display something to the user, whatever. And then, I still want to close my file. So sometimes you find yourself in a situation where at the end of every one of your catch block, there are like a few lines of code that you keep repeating, okay? And if you think about it, even if everything goes well, you read your data, you write your data to the file, you still want to close your file after you're done working with it. So those same like few lines that you have at the end of each catch block, they would even be after the end of the try-catch thing. So when you realize that you are in that kind of scenario, this is when you want to use a finally block. No matter what happened, whether there was an exception or not, after we are done, executing all of the statements in the try block without problem, we are going to execute the statement in the finally block, and then we're going to move on to the next stuff after this try, catch, finally structure. If we have an interrupt here, if we have an exception here, we're going to jump to the appropriate catch. We're going to trigger it, and then we're going to jump to the finally statements, execute them, and then we're going to jump to the rest. Okay? And even if we have to rethrow, even if we have to declare and just pass around, the exception because we don't have any appropriate catch to handle it, even in those cases, the finally statements are going to be executed before we move on. So it's very useful to have consistent behavior pretty much when you are handling those kind of exceptions. So we are going to do two things to kind of pack together. And then the next step will be for us to write custom exceptions. So the two things that we're going to do, the two examples we are going to look at to try to kind of wrap together everything we've covered so far are going to be, the first one is going to be a very simple example, but we are going to trace it in every possible way we can. We are going to generate different scenarios, and I'm going to try to be exhaustive and show you everything that can happen with a simple try, catch, finally structure. So here's a try-catch finally structure. A bunch of statements here, some statement to handle an exception called the exception, some final statements, and next statement after the end of the block. So first thing we are going to say is, well, let's say that there are no exception happening. So what is the flow of execution? What is the control flow here if no exception happen? Well, I'm going to execute this, and I'm going to execute all of them. Since none of them threw an exception, I get to complete my try block, okay, all the statements in the try block. And then the definition of the finally block was, once you're done executing everything, those statements are going to be executed. So be it, okay? I'm going to execute all the statement inside the finally block. And then I'm done with the try catch finally structure. I move on to the next statement after it. That's the easiest case. Everything goes well, everything gets executed in both the try block and the finally block. Scenario number 2. So this time we have like several statements here in the try block. Oops, sorry, I went backward instead of forward. We are going to say that statement 2 issues an exception, raises an exception. Okay, that exception is going to be called exception 1. So it's convenient because we catch it here. So statement 1 executes, statement 2 start executing. In the middle of execution, if it's a method call or whatever, it fails, raises an exception. So we skip statement 3. and we look at the first catch block to see if it can handle that exception. We are lucky, the first catch block can handle that exception, therefore we move on to executing the part of the code here in yellow that is handling that exception. So we had an exception, we know how to handle it, we execute the entire block of code here in the catch block that is supposed to make everything better. And then, well, that's the definition of finally. Finally means like finally when I'm done with or without error, I'm going to execute this. So I execute all of the statement in the finally block, and after that, I resume execution after like anything, like nothing happened. Okay, that's the point of exception handling. So these are scenarios that we have seen. Now let's try to throw in a curveball, a scenario that uses that third technique that we just talked about today. The technique that consists in partially handling an exception and then referring it so that whoever called us can finish the job. So we have three statements. We're going to say statement 2 again raises an exception. This time it raises an exception called exception 2. So I execute statement 1, I start executing statement 2, it fails with an exception, I skip statement 3, and I jump to the first catch block to see if it can handle exception 2. It can't. It can handle exception 1. So I go to the next catch block. Can it handle exception 2? In this case, yes, it can handle exception 2. So I execute all the statements that are meant to handle the exception, and then I'm about finished. The last statement here is a throw. Throw exception. Whatever exception I received, whatever exception object I received, I'm going to rethrow it. That's the third technique we discussed. That does not get executed. Everything in the catch block gets executed, but the throw statement. Instead, we are going to enforce the fact that the finally block promises us that no matter what happens, those statement will get executed before we move on. So we jump from here to executing all the statement in the finally block, and then we come back here and we throw the exception. The moment we throw the exception, we are going to bump out of this method, right? So the next statement here never gets a chance to be executed. The throw exception is going to cause whoever called us to suddenly have us return to them with an exception object. Which exception object? The one that was referred to by the variable x here and received here in the catch block. Okay? So it's a little weird. That's the only one that's a little weird. The first two, by now you should be familiar because we have been running like 2 or 3 times over similar scenarios. Okay? So that's good. The third one, I just wanted to stress how different it is from the previous one. So when you rethrow exception, go into alert mode, okay? Not everything is as it seems. The finally block and the rethrowing exception can have a weird interaction with one another that you have to be aware of. All right, so that was our first example. The second example is just a check to show you how alert you need to be when you are using exception. So I'm going to show you a code example. I'm going to narrate through it like if everything is normal in it, like if everything is okay. It's going to be a very simple code example, okay? But somewhere in it, there is an anomaly. There is something weird that should raise questioning, okay? If you understand everything, no, you will answer your own question. If there is any chance that you are still a little shabby, on exception and stuff like that, that is going to trigger question. All right. So we are going to go back to our good old circle example, as always. We have the set radius method, and we don't want to allow a radius that is negative. And we already integrated into that exception handling last lecture. We are going to do it again, and we're going to keep pretty much our eyes peeled for potential problem. So I'm going to start with the circle with exception class, which is our new version of the circle class, okay? It has an attribute radius. It has also, I'm going to throw something new here, it has also a private static attribute called number of objects. So this has been like a few weeks ago, so maybe you don't remember, but what I told you about static attribute is when you have a static attribute, you need to initialize it like this, right where you declare it. unlike non-static attribute, which I ask you to not initialize like this, but instead initialize inside the constructor. Why the difference? Because static attributes do not exist inside the objects. Remember? The static attributes exist, to present it in a simplified way, we said they exist inside the class. So when you start your application, you have not created any object of the class circle with exception. There is still somewhere in memory a private static int number of object that has been initialized to 0. Before the first object was created, before the first constructor had a chance to finalize the first object. Okay? That's why we cannot initialize it in a constructor, because maybe that constructor will never be called. I still need that variable to exist, and I need it to be initialized to 0. So static attributes are special. Okay? They don't live like variable inside of object. They are pretty much like variable that exist in an abstract thing that represents a class. Okay? And they are accessible by every object, like if it was an attribute. This is an attribute, this is just a static attribute. And all the objects, therefore, share that one variable. If one object changes the value, all the other objects show that the value was changed for them as well. So we are going into a flashback here about static things a little bit. Then we have a constructor, so this is standard, constructor no arg. If you don't tell me the radius, I'm going to chain with the 1arg constructor and tell it the radius is 1 by default. Okay, we have been doing that for like the last few IEs, so it should be like routine by now. The 1arg constructor takes one argument that represents the new value, the value for the radius. Okay, what it does, it uses a method from the class called setRadius, which we are going to cover in the next slide. I pass to the setRadius whatever radius value that you gave me, and then I increment number of object the number of object static attribute. So what I'm doing here, and the reason for which it's called number of object, is that every time you create an object of class circle with exception, you are going to end up calling one of the two constructors. If you call that one, it calls the other one. If you call the other one, well, it's already called. Okay? So that means that anytime you create an object, you will end up executing this constructor directly or as a second step. Every time you create an object, I'm going to count one more. So I'm incrementing that counter that is shared by all the instances of the class, and I'm saying one more object just was finalized by a constructor. One more object was finalized, and so on and so forth. So that variable, at any point in time, is going to show me how many times I executed the constructor, which means how many times I created actually an object of that class. So it's a neat little trick with static attributes that we use often to demonstrate, what you can do with static attributes. You can actually keep track of how many objects were created. All right. And you're going to see how we use that actually to help us understand the rest of the code. So now we have the boring stuff here. So get radius, return radius. Get number of object, return number of object. Please note that this is a static method. So that means that I can get the number of objects even if I don't have any object of that class. It's just going to return 0. Then find area is going to compute the area and return it. So nothing really exciting there. And now let's look at setRadius and let's look at what how we can integrate exception into it. We already did that once. Let's try to do it maybe slightly differently here. So public void setRadius takes a new radius value as argument. I declare that this method throws an illegal argument exception. Then I test if the radius is greater than 0. If it is, perfect. If not, throw a new illegal argument exception with a specified text message here. And then, inside the main, I'm going to create 3 objects. The first one with a radius of 5, another one with a radius of -5, the last one with a radius of 0. So I don't expect the -5 to go through. I don't expect the 0 to go through. Only the first object should be actually created, right? So now my constructor calls setRadius. setRadius raises potentially an exception. So I have the potential for setRadius to raise an exception and the constructor to pass it, let it bubble up to me. For that reason, I encase everything here in a try block. I'm going to try to do those things, but I know some of them might, and in this case will fail. Okay? So try block, construct those three objects. Catch. If I get at any point an illegal argument exception from one of those three statements, I'm going to get the object under the variable x, and I'm going to display it. So this is something that we do very commonly with exception. You get an exception. If you don't have anything smarter to do with it, what you do is system.out.println, and you pass the reference to the exception object. Automatically, system.out.println is going to call the toString method on that object, and the toString method in any exception class is already there, ready to give you pretty much a little blurb that explains what happened. Okay, so that's how we're going to get on the screen some details about the exception without having always to rewrite, something that says arithmetic exception occurred, possibly division by 0. No, this is going to be done automatically for us in a standard format here. And then, if everything went okay, or if I had an exception and I just handled it by displaying the text of the exception on the screen, then I display this is how many objects were created. So I use that static method. I call it on the class directly, okay? And I say circle with exception dot get number of object, display that on the screen. So if everything went fine, the number of objects should be 3. If the 0 didn't go through, it should be 2. If the -5 didn't go through, it should be 1. If even the first one didn't go through for whatever reason, then it should be 0. Okay? We run this, and this is what we get. So that system.out.println x here is resulting in this message being displayed. So in that message, you have two parts. You have the java.long illegal argument exception, which is what actually any exception will do in its toString method. It will start by putting the name of the exception class that was thrown, and then colon, and this is a message that we specified in our throw statement. So this is a little bit more specific to what the application is doing. It's telling me pretty much there was an illegal argument exception. It has to do with the radius. So both parts, the part that is filled in by the system itself, the part that is added by the programmer. And then once I display that, exception is considered handled. Okay, I can resume execution. I come here and I display number of object created was, and in our case, it's going to be 1. Which means that object creation went through. Okay, the second object creation never completed. I tried to create an object with a negative radius. I got an exception thrown back to my face. Okay, because of that, I skipped whatever was left here as far as statements go in the try block, and I jumped directly to the catch block. So the third one didn't even get a chance to be executed. The first one worked, the second one failed with an exception, the third one never ever got even attempted. Okay? All right. So this is a very basic scenario. There is one thing I want to draw your attention to, okay? And it has to do with this part of the code. So here we have the constructor. The constructor calls setRadius. setRadius throws an exception. It declares that it throws an exception. Indeed, in the code, it throws an exception. So what can possibly look weird in this code? Is there something missing? So what do we do when we call what do we have to do when we call a method that is going to potentially throw an exception? Aren't we obligated to do something? Yeah? Yeah, we can do it three ways, right? We can try and catch it, or we can declare it, or we can try and catch it and rethrow it. This guy here is not doing anything. Yeah, it doesn't have a try catch, so it's already gone for two of the possibility. And then does it declare actually that it's throwing an exception? No, not even. So the reason for which I'm going back on this, and I'm going to make a fuss about this, okay? The idea is that you are going to encounter that all the time. This is maybe the number one source of confusion when you're just starting using exception. Why is it that sometimes I have to use all of that code and sometimes I don't? The answer is very simple. There are exceptions that are checked, and there are exceptions that are unchecked. So bookmark that page on the textbook that lists like the exception, okay? When you are at work later in your career, you'll just have a bookmark to the Java doc reference, pretty much, and then check it every time, okay? Make sure that you know if it's an error, it's unchecked. If it's a runtime exception, it's unchecked. If it's not a runtime exception or it's not an error, most likely it's checked. And when we do our own exception class, our custom exception class, it's going to be always checked. Yeah?
Why does it say we have to declare it in the constructor when it's already declared in the final?
So we would have, if it was a checked exception, right? So if here we were throwing something that was actually a checked exception, this constructor here, because it uses a method that throws a checked exception, it will have to redeclare it here. First way of handling. Yeah. I would add here throws, and I'm going to use the name illegal argument exception, right? But illegal argument exception is unchecked. So the problem, the thing that confuses everybody is that you are going to encounter code where some programmer handle unchecked exception. Does that mean that you have to handle them as well, okay, in your code? That's just the little gray area with exception handling, is that when it's a checked exception, you have to do it. The compiler will force you. When it's an unchecked exception, you may or you may not handle it, depending on what your code calls for, what your job is. For example, this programmer decided here that it was going to report the illegal argument exception. It's going to declare that it actually potentially raised it. Didn't have to do that. It's deciding to throw it. Well, that's fine. If you need to throw one of those, throw it. So it's totally kind of like gray area between the two programmers, the one that writes this code and the one that writes this code. Who wants to handle this exception? Okay. If you don't handle an exception, again, remember, it just bubbles up to the top, then your application shut down and displays the exception message. Yeah.
Do you have to have finally statements, or?
You don't have to have a finally statement, but you use them generally when you use resources. And we're going to have like one more syntax to completely at the end of the session, where I'm going to show you a more convenient way, to open files and not have to worry about closing them, pretty much. But the idea of the finally block is, again, it's to avoid repeating code, okay? If you have the same code that needs to be done no matter what, whether there is an exception, whether there is not, then you put it in a finally block, so it's guaranteed. It's guaranteed. The way that it's interesting is that it's guaranteed even if you rethrow. You see, there's a weird thing that happened when we rethrow the exception. Okay, so you execute your statement in the catch block, and then before to throw up, you're going to execute the finally block and then throw the exception. So Java takes care of guaranteeing pretty much that those lines of code are going to be executed no matter what when we are done. So it's convenient. If we were putting the code after the try-catch block, right, it's not the same. It's not the same, because if I don't have any problem, yes, it will be executed. If I have an exception and I handle it in a catch block, then yes, what comes after is going to be executed. But if I have an exception and it's not handled in the catch, or I have an exception and it's rethrown in the catch, then I will never get to the statement after my block, right? So in that case, that is where the power of the finally clause really shines, okay? There's no other way for us to guarantee execution of some statements. All right. Defining custom exceptions. So there are times where you are going to want to define custom exceptions. Okay, you're going to think, I have something weird potentially happening in my code. I know that I can handle that with exceptions. Let's create a new class that is a subclass of exception, and that class is going to represent a new exception. And by the way, exception classes can be awfully trivial. Okay, you can have an exception class that is a custom exception class that has nothing in it. The simple fact that it exists, that it has a name, makes it a placeholder. You can throw it, you can catch it, and that's what matters. Okay, the type of the object, the exception object, is what matters when you throw and you catch to try to communicate an idea of what happened. So the name of the exception matters. That's why sometimes people want to make custom exception, like configuration file not found, configuration file not available. It's more specific than just saying IO exception, okay? And that allows you, as the other hand, to catch the specific exception, do something about it, like generate a default config, and then if this is an IO exception instead, you do something completely different. Like you tell the user, I cannot proceed because I cannot even find, the disk on which this file is supposed to be. So there are advantages, but the rule of thumb is start by looking at the list of exceptions in the JDK. You've seen us use, for example, illegal argument. Yeah, illegal argument is really a catch-all. You give me a bad parameter, illegal argument exception. You give me a bad value, illegal argument exception, okay? You give me the wrong type of parameter, illegal argument exception can even be thrown, okay? So that means that most of the time, you're just going to go check the list of exceptions in the JDK. You're going to find one that has a name that kind of captures what's going wrong right now in your application. You're going to throw that one. And you're going to document it, because it's arbitrary, right? I could throw an exception named XYZ, and I know that when I throw exception XYZ, that means this and this and this particular things are wrong. So it's just a name. So you have to not only pick a name that makes sense, but also document in your application, put a comment, or like do formal documentation if you are really working on a real world project, that's going to say to whoever uses your code, this is what happened when this exception is thrown. This is why I chose that name. This is the scenario that's happening right now, okay? All right, so whenever possible, use the JDK. If it turns out that you don't have a name that really matches what you want, or you want a name that is a little bit more specific, like instead of IO exception, configuration file not found, okay? Then yes, then you add your custom class. And your custom exception class can be like pretty much an empty class that just inherits from exception and has a new name that you can now use as an exception name. So just interested in the name, it's the next level. And then there is a level at which you say, for example, when I throw my exception, what can we do when we throw an exception? We create a new object of class exception. What does a constructor take as parameter? A string. Like a piece of text that allows me to explain this is what happened, like the radius, for example, cannot be negative. Okay? All right, so that's all I have. That's all I have with exceptions. Every time I create an exception object, that's all it can do. It can only take a string as parameter. But what if I had an exception happen? And that exception happens because of, let's say, the value of two variables. Okay? Like those two values of those two variables creates a scenario that my program cannot handle. So I want to throw an exception. But I would like to give, inside the exception object, I would like to keep record of what were the two values that caused me a headache, so that somebody else can then read them and debug, the problem. So that means that my exception object should have two attributes that hold those two values. That means that the constructor should allow me to specify those two values. So it should take, instead of taking just a string, it should take two values of type, for example, int. And then later on, when I want actually to display those values or something like that, when somebody in a catch block wants to extract those values from within the exception object, guess what? It would be nice if they could call a method like get values that's going to allow them to get those values somehow, as a string, as an array, as something, okay? All right, well, we are like talking about major customization here, okay? It's not that bad. When I say major, I don't mean it's going to be complicated. The class is going to be 5 lines, okay? But what I'm saying is that we are straying away from what a basic exception class does. So I really want, in that case, to define my own class, say that it's an exception, so extend exception, and then add some attribute, add some method, change the constructors, chain with the superclass constructor properly, so I can customize pretty much infinitely. Anything I want to do there is possible because I can extend the class. And that brings us to illustrating one of the things that I mentioned like long ago, actually, which is sometimes you learn about inheritance not because you want to write classes and then subclasses and stuff like that, but because you want to use a framework or a library. And that library allows you to customize things by inheriting from classes. That's exactly what the JDK does for us with the exception. Okay? We have basic exceptions. You can customize very simply. You can customize in a very complicated manner, but it's going to be the same mechanic. So let's apply that to our set radius once more. So we are going to say that we have the set radius method, and it throws an exception if the radius given as parameter is lesser or equal to 0. That should be lesser or equal here. But now what I want to do is I want to save the value that was given to me. So if somebody tries to create a circle with a radius of minus 23, I want to document what happened. I want to save inside my exception object the value that was used, minus 23, so that when I pass my exception object to a handler, the handler is going to be able to go and dig in that object, find what is the value that caused the problem. Okay? And generally, this is what we want to do with exception object. We want to store some information, more details about what went wrong, so that later on, the try-catch block, can actually maybe take some more steps based on the values that were used. Okay? So, we are going to create an exception, a custom exception. So always make sure that the name that you come up with doesn't exist already. But refer, to what I was saying in 2 slides ago. You should never go and jump directly to creating your own custom exception. You should first look for one that exists with the proper name, and then if you don't find any, then make up your own name, but make sure it's different. So here I'm going to call it invalid radius exception. Pretty specific to my application and to the problem that's happening here. Okay. This public class is going to extend exception. So it doesn't have to be a public class. It could be a no visibility modifier class, inside another Java file that has already a public class, no problem. But it has to extend the class exception. This is what makes my class usable with all of the keywords that we learn about exceptions. So I will be able to throw a new object of that class. I will be able to catch it. It has to inherit from exception. Inside of it, I want to store the radius that was used to try to create that circle that turned out to not quite work out. So private double radius, that's how you declare an attribute. Nothing fancy here. This is just a regular class. Okay. Public invalid radius exception. So I want a new constructor. I want a new constructor that takes as parameter the value of the radius that caused me all those trouble. And what it's going to do, it's going to set the attribute radius to the value of that parameter radius. So that's how I'm going to store the information. When I throw this exception, I'm going to throw new invalid radius exception, open parentheses, and I'm going to pass the number that caused the failure. And this is how it's going to be received. But I am a subclass, right? I am a subclass, so I still need to let the constructor of the superclass do its job. So I let Java call it implicitly with super empty parentheses? Well, I can do a little better than that. I'm going to call the constructor from the superclass, and between the parentheses, I'm going to give it what any exception crave. Any exception class in its constructor wants a string of text that tells me a little bit more about what happened. In this case, I'm going to say invalid radius, so it's very similar to what I was doing before, and then I'm going to concatenate at the end of that string the value of radius. So I did 2 things. I saved the value of radius inside one of my attributes, so I can use it later on if I need to, okay, to recover from the error. And second thing that I did, as a subclass of exception, I still made sure that the constructor from the class exception was called and was given what it wants, which is a string explaining what happened. And in that string, because I was given the value of radius, I was able to be even more specific. I was able to say the radius, something is wrong with the radius. Here is the value that was given to me. Okay? Last piece of the puzzle, get radius. So I can add methods, right? If I subclass something. So I'm adding a method that doesn't exist in the superclass exception. So I'm not trying to override anything. I'm just adding a method that allows me to access this private attribute radius. Who is going to use that method? Well, at some point, somebody is going to do a try catch. They are going to catch my exception object. If they want to know what is the value that triggers the problem, they are going to call getValue on the exception object. We didn't do much with the exception object until now. Generally, we receive them, we display them, or we just ignore them, and that's how we handle our exception. Well, now we can even call method on them. Okay? But it's because I'm adding those methods in my customization. So, I already went over all this. How do we use this? So here's a circle with custom exception. So that's the circle class, okay, new version. I'm going to still have that radius here. Then I'm going to still have that number of object here. And then I have here a circle with custom exception constructor. It's going to declare that it throws an invalid radius exception. Can I skip that? Can I avoid declaring that I throw this exception? No. Why? Because it's a checked exception. How do I know it's a checked exception? It's a subclass of exception, but it's not a subclass of runtime exception. And it's definitely not a subclass of error. So if it's not in error, if it's not in runtime exception, then it is actually a checked exception. I have no choice. I have here to say that this constructor might throw this exception. I have to declare it. But what I do inside, I never throw the exception myself. What I do is I chain with another constructor. Okay, so I chain with that one arc constructor. Well, that one arc constructor, again, may throw the exception. So it declares throws invalid radius exception. But it doesn't throw it itself. It just calls another method, setRadius, which is likely to throw that exception, which has a potential to throw the exception. So you see how the constraint propagates, right? At the core, it's only setRadius that is going to potentially throw our custom exception. But the second constructor uses setRadius. It doesn't know what to do with an invalid radius exception because it has no control on the radius value that was given to it. So it just says, I'm going to rethrow. I'm going to declare to pass the exception along to whoever called me. This guy here is calling the second constructor. It keeps chaining. Can you do something if the exception happens? No, you have to do something. It's either you handle it, you declare it, or you rethrow it. Well, in this case, we are going to declare it again. So pass it to whoever called us. And that's going to bubble up to the main, which hopefully is going to be able to do something. Okay? So why is the constructor declaring the exception this time? Because it's checked. How do I know it's checked? Because it's not a subclass of runtime exception. It's not a subclass of error. As a matter of fact, everything that you create in custom exception in this course will be checked. So that's another shortcut, another easy way to remember. Here comes the easy stuff. So get radius, return radius. Get number of objects, return number of object. It's static. Find area, compute the area. So it's exactly the same than what we had before. We haven't modified that part of the code. And then here comes the setRadius. So this time setRadius looks the same. It declares that it throws invalid radius exception. Again, no choice. This is a checked exception. It tests the value of the radius parameter. If the value is wacko, then we are going to throw new invalid radius exception. And I pass this time as parameter to the constructor, I pass the value of the radius that is invalid. So over times, every single over time that I created an object of class exception, I pass a string of text, because this is what exception wants. Here, I pass a value. And then the constructor itself will pass a string of text to the superclass constructor to make it happy, and store this value inside the object. And this is how I'm going to use it. So I'm going back now to the main. Public class test circle with custom exception, main method. Still trying to create those 3 objects, but I know now that only the first one is going to go through, and then the second one is going to fail with an exception, and the third one is never going to be ever attempted. I catch an exception here, which is invalid radius exception, do something about it, and then after that I display the number of objects that were created. So the question here is where is my extra information? Where is it going to pop up? Okay. Well, it's when we throw the exception that we pass it. We pass it to the constructor. Then the constructor passes it to the superclass, not as an int, but as part of a string. So when you do finally here system.out.println ex, you ask the exception object that was given to you to display itself. So you ask it to use its toString method. We didn't write a toString method, but we inherit one. We inherit one from the exception superclass. And that toString method is going to rely on the fact that every exception gets a string of text in its constructor, and is going to display a message that uses that string of text. When we pass that string of text inside of our subclass constructor, we made sure to include into it the number that caused all those problems, the bad radius value. So this is how it's going to end up showing up on the screen. If this is a little weird, take the code, put it in JGrasp, run it with the debugger, step by step, okay? With all those exercises, chaining constructor, chaining from superclass to subclass, etc., the debugger is actually the authoritative way to know exactly what's happening. The more you practice with it, the more likely you are to be able to predict what's happening on your own afterward. So, what are the things that we need to pay attention to avoid further problems, errors, common misconception, and stuff like that? The first thing is it's always the same. You discover a new technology, and it's not just you, it's everybody. Like the field as a whole, we all do that. You discover something new. For example, deep learning is really successful right now. Well, everybody tries to apply deep learning to something. Okay? There's not even a question about what tool you should use. Deep learning is the answer before even you consider the problem characteristic. Okay? Well, it's the same thing with techniques like exception, inheritance, etc. Now that we know how to do exception, the temptation is to say, forget about those good old if statement and trying to be careful about avoiding errors, the good old-fashioned way. Now I can raise exception, handle exception, etc. Yes, it's a lot cleaner. I'll give you that. It's a lot cleaner. It scales up very well. It's a good technique. But like every good technique, sometimes there is too much of good, and it's bad. Okay? Meaning that if you start throwing exceptions all the time without thinking whether it's worth it or not, what you incur in your application is an overhead. Think about it. When you throw an exception, you stop the regular execution, so you have to bypass pretty much the regular return from a method, okay? Then you create an object of class exception. When you create an object of class exception, that exception could be a subclass of a subclass of a subclass, so you are going to chain 3 constructors, from subclass to superclasses just to get that object created. Then you pass that object somehow to the try-catch block. You review your try-catch block, all the catch clauses, to see if one of them match. So every time you test, does it match, does it match, does it match? If it doesn't match, you propagate to the method that called you. If there's no match there, you propagate again to the method that called you. All of this is actually costly. Costly in terms of execution time, okay? So are you going to notice that if you are developing a little desktop application that just helps you compute your taxes? Probably not. Okay, so you can afford to use exception to have the luxury, I would say, to use exception everywhere if you are developing a non-critical application. If you are developing on an embedded system, like an IoT device, if you are developing even on a cell phone or anything that needs like a lot of responsiveness, like a game, then you don't want to do that. You want to think twice before to incur all of those extra steps that are going to take time. So when to throw exception, one good guideline is if you can resolve the problem right here, right now, if you can detect a problem and resolve it right there, then don't throw an exception. The only time you should consider throwing an exception is if you are in a method and you can detect the problem, but you cannot remediate it. For example, it's bad user input, or the caller, gave you bad parameters. In that case, yes, you want to inform the caller that something happened. This is exactly what exceptions are good at. So here's a code example here that's going to illustrate that. What you have on the top one is how to handle a problem economically. And what you have on the bottom one is how to handle the problem like you just don't care how many resources you are using, committing, wasting. Okay? So the economical version is if my reference variable is different than null, then use it to access the toString method inside the corresponding object. Else, I cannot access the toString method of that object. I'm going to return a default value, like for example, an empty string. If you have code like that, do not change it. Do not go to exception. The exception version would be something like that. Try to return ref var.toString. If that fails, catch a null pointer exception X and return the blank string. Incidentally, this is a null pointer exception, right? What's the deal with null pointer exception? They are unchecked. That's another ID, that's another hint that maybe, you are like doing something that is a bit overkill here. You are handling an unchecked exception. Well, this is exactly what it looks like when you try to handle an unchecked exception, as opposed to rewriting the code so that your code doesn't fail to start off with. Okay? And in that case, yeah, it's always preferable. All right. That's the first time we're going to finish that early. But I am done with module 4. Everything up to now is at the menu for the next IE. Okay? So everything up to that SolveForks thing. The next step is we are going to start dealing with applying exception to file handling. I'm going to get that started Tuesday on the next lecture. For now, I'm not going anywhere. Let's just have a Q&A session. You are free to leave if you are done, if you are sick of it. No problem. But if you have questions, please hang around. We have some time here, so we might as well make good use of it. Thank you, everyone. Yep.